All right, guys, I'm going to do some video explanations on your test review packet. As it just kind of remind you some things that was explained today in class. One, test is tomorrow. This is going to be a 6 weeks exam. Okay, it covers your unit 5, 6, and 7. It'll be a separate grade, but it can also, this is important, it can also replace your lowest grade for a 75 if you have still failing grades for a previous test. Okay, so, and the main thing I need to make sure we understand is this test is going to be online and they're going to be star-like questions. So we're going to look at the new format of questioning. We've done a couple of those with our quizzes where you have to type in an answer or match an answer. So we've kind of practiced it with our quizzes that we've done. All right, the first part of your review, section 1, is your exponent rules. We discussed this. You need to pause the video and copy these down again, but you need to know these by heart. Know that the product rules, when we're multiplying, we see multiplication with this little dot here. Okay, sometimes we show it also with parentheses to show multiplication. So just understand that if you're multiplying exponents with the same base, you have to add the exponent. So you had to fill in this rule, which should be the base is x, and then the exponent should be a plus b. Our power rule, we know it's the power because I see parentheses, and I have an exponent. Sorry about that. Exponent outside the parentheses. So we're distributing that exponent in, and so that means our rule will be x to the a times b. We add the multiply the exponents together. And quotient is anytime I have some type of division. Okay, this fraction bar is like a division bar. And if I'm dividing exponents with the same base, we subtract the exponents. And then negative exponents, we cannot keep an exponent with a negative. Okay, that's supposed to be a negative x there in case we didn't see it. So we needed to understand to change this to a negative, you make it turn, you use the reciprocal. So remember to flip it and then change the exponent to positive. And then combining like terms, we've done that all year. Okay, I gave you an example of that. Make sure you do not change your exponents with that. So I'm going to go over a couple of these. Just make sure you understand. We did a couple of these in class. This first part is really just combining like terms, but you do have some multiple steps. On one, we have like terms with the a and the b. So that should have just simplified to negative 2ab. On 2, our like terms are with the xy squared and the 6 right here, xy squared. So a negative 2x squared plus that 6x squared. This simplifies to 4x squared y, or xy squared, excuse me, minus just that 4xy, because this one in the middle did not have a like term. Make sure we write correctly. On number 3, it says subtract the negative 6b to the 5th. Okay, so when you write that, it should be written as ab to the 5th minus that negative 6b. So because we're subtracting a negative, this actually turns into a positive 14b to the 5th. So we just mess with the coefficients when we're doing that. I'll go over 4 again. Some classes did this, not every class, just depending on your questioning. But when we multiply the coefficients together, and then we follow the exponent rule with our variables. Okay, so times our n. When we multiply exponents, we add the exponents. Exponents with the same base, sorry. So this, when we first did it, would have simplified to negative 35 into the negative 6. And the negative 6 here, exponent, is what needs to be addressed. So we have to think of that over 1, and then we need to take the reciprocal. So that comes down and come up. So when we simplify that, this actually was just negative 35. Now it's still on the top of the fraction, and into the 6th power is on the bottom. This was our final answer. Here we needed to, on 5, we needed to do this exponent rule, the power rule, excuse me, first. I don't know if y'all see here, this parentheses, we're going to distribute this power of 2 to each term. So that's 5 to the second power. And then whenever we distribute or raise a power to a power, we actually multiply those two exponents together. Then everything else is going to stay. So this is going to be times 2v to the third, and then times v. So now when I simplify this part here, this is actually 25v to the 8th power. And then we're multiplying, sorry. So when we multiply here, all these v's, same base, we just add the exponent. And some people forgot that this v here had an exponent of 1. So our final answer here should have been 50v to the 12th power. Okay. All right, so number 6 was similar to number 5. You need to do your power rule first. When doing that, this comes out to a positive a, because it's like a negative 1 to, if I square that, then becomes a positive a positive 1a. You want to put the 1 there. We don't need the 1. So we have a positive a to the 12th power and b to the second power. And now we're just adding that to the 9a to the 12th, b to the second. And hopefully we see now that these are like terms right there. And we should end up with, it's not on there, 10. I thought I had it on here already, but nope, it's not showing. We should end up with 10a to the 12th b squared. This is our final answer here. So simplifying monomials. All right, and then we're going to continue using those exponent rules on this next page. We got some multiple steps on here. I'm going to go over a couple, or maybe just make reference to the rule and see if we can get to it. So on number 7, the actual first item that we should focus on is this parentheses square. So we should do the power rule and distribute this exponent of 2 to each term. And when I do that, I keep the first one here, a negative 2y to the 4th. Multiply that now to x squared y to the 6th power, because I do the 2 times 3, minus 13x squared y to the 10th. Now what needs to be recognized is we have a multiplication, and multiplication is before subtraction. So I need to do the product rule first now. This is going to result into negative 2x squared y to the 10th power. And I'm subtracting that from the 13x squared y to the 10th power. So hopefully I'm getting you to see that this x squared y to the 10th, x squared y to the 10th, those are like terms. So this is going to result in the answer, negative 15 x to the 2nd power y to the 10th. I know I kind of ran out of room there, but just check your understanding on there. For number 8, because I see this fraction or division bar right here, we should use a quotient rule. Quotient rule requires us to subtract the exponents. I don't think I have the answer there. So here, this would have resulted into r to the 1st power, but I don't have to, because 6 minus 5 is 1. I don't have to put an exponent of 1. You should know it's there. And then s to the 3rd power. And here your t's end up actually canceling out. Or if you put t to the 0, you had to remember any number to the 0 is 1. And 1 times anything stays itself. So that was our final answer. On 9, we should be doing the power rule first. Distribute this 2 to each term. And let's just see if you get the first rule correct. Our numerator is now going to end up being 9x to the 12th power. Underneath here, we're doing the product rule because we're multiplying. So our denominator should be 15x to the 6th power. So one thing you have to make sure you don't forget is to reduce your fractions and simplify. So I can, now that I'm still dividing these two x's, x squared and x6, I'm subtracting. So this actually reduces to 3/5 x to the 6th power. Or you can, this is the same answer, we could write this as 3x to the 6th power over 5. Okay, those are the same. Now on 10, I'm going to walk through this, especially because you have to, the parentheses, I'm not sure if everyone sees this, but your parentheses is around the whole fraction. So when we distribute the power, we have to do it to the top and to the bottom. And when we do that, our numerator becomes 16x to the 8th power, y to the 4th power. All over, well, if I square my 6, that becomes 36x squared, y to the 2nd. And then we're back to having to recognize to reduce this fraction and then subtract our exponents. So I might run out of a little room here, but this turns out to be the answer is 4/9 x to the 6th power, y to the 2nd power. Okay. Or if you want to write your exponent with the numerator, that would be 4x to the 6, y to the 2nd over 9. So 11 is similar to 10. It's just you don't have to do the quotient rule first. You just need to go straight to your product rule. And what I would do, and there's different ways to get to this answer, but product rule says we multiply the coefficients. So that gives me 21. And then now we add the exponents. This would be k to the negative 10. And we still have 6k to the 2nd power underneath in the denominator. All right, so now we're doing our quotient rule, which we're going to simplify the coefficients. That's a 21, sorry. But now we have to subtract. So like I'm simplifying 21 over 6, and then for my k's, I have a negative 10 minus 2. So when this gets simplified, this really is going to reduce to 7 over 2. And then we have k to the negative 12. And we have a negative exponent. And so when that happens here, we got to remember to take the reciprocal. So we're going to flip it over 1. And it's going to come down to the denominator. 1 comes to the top. So the final answer, and I'm just going to kind of write it over here so I have more room, is 7 over 2k to the 12th power. So this, you have some negative exponents on number 12. So let's go ahead and let you try that. Okay. You can reduce the coefficients. Right, it's gonna stay negative. So hopefully we're getting to a negative 1/3 into a negative 2, but then we can't keep this negative exponent of 2. So we have to take the reciprocal. So really our final answer here is 1/3 n squared. Or 1 over 3n squared. When you get to 13, you're going to need to do the power rule first. So when I rewrite this, we keep everything on the top the same. But here this becomes a to the negative 4 and b to the negative 4. And this is now the quotient rule. So we're subtracting the exponents. So I'm just going one letter at a time. So like if I look at this first letter, which is the A's here. Oops, I probably should do that in a different color. Let's go orange. Okay, if I'm looking at the A's, this is A, and then we're subtracting the exponent. So it's saying 12 minus a negative 4. And then we do the same thing for the B's. This is negative 3 minus a negative 4. Well, when you simplify that, we're going to get a to the 16th power and b to a positive 1 power. We don't have to put that 1. Sorry. So this would be our final answer. So don't try to do your reciprocals, like flip it, get rid of the negative exponents into the very end until you've done all the rules. All right. So on 14 here, you're going to need to do this parentheses first, raising everything to a power of 3. Now, 1/2 to the 3rd power means we're taking 1/2. I'm just going to show what that means. We're saying 1/2 3 times. We're multiplying 1/2 3 times. Okay, so this comes out to 1/8. But if, hold on just a second. Okay, sorry about that. So, but you could do this on your calculator. Let me get out of the equation mode. You can do your parentheses and then put your fraction inside the parentheses by hitting alpha y equals to get your fraction box. Put a 1 on top, 2 on the bottom, arrow to the right to close the parentheses. And then we're going to raise that to a power of 3. And it will give you the fraction answer. Okay, so if you're not strong about understanding what it simplifies to when you have a fraction coefficient or fractions appear, let the calculator do the work for you. So we know that this is going to be 1/8. Oops, sorry. Oops, I don't have my pen. Back to what we're doing. 1/8 here. Now m to the actually 12th power and n to the 15th power. Everything we have in front here, the minus, it's just going to stay. But what I'm going to do is I'm going to simplify this section because we have the product rule right there. And so this is going to give me 3/4 m. Here we're adding the exponent, so m to the 12th power, n to the 15th power. And hopefully you see now, because our exponents, our variables and our exponents are the same, we have like terms. So now we're just subtracting. And so we have to subtract the 3/4. So if you go into your calculator, minus the 1/8, it will do it for you. Okay, if you're not strong about fractions, don't let the fractions scare you. So we get 5/8 m to the 2nd power, n to the 15th power. I know I kind of ran out of room there, but that is our answer. And then we are going to do our power rule first here. And this is going to end up giving me a positive 16y to the 6th power. Then we're going to multiply that to x to the 3rd, y to the 12th power. Then we're going to add that to 7x to the 3rd, y to the 18th. So from here, we should be doing the product rule. Multiplication goes before addition. So this simplifies to 16x to the 3rd, y to the 18th. And that can be added to that 7x to the 3rd, y to the 18th. Because now, hopefully you see that these are like terms here. So our answer is just 23 x to the third, y to the 18th. We do not add the exponents when we're doing like terms, combining like terms. We only add exponents when we're multiplying, okay? All right, so just to review the kind of what we did in class today, we talked about you will have one geometric, maybe two, applications. Perimeter here is when we add up all the sides, we go around. So if I was looking at 17, the perimeter of the rectangle would be adding all four sides. So you might have to repeat the sides and then combining your like terms. So this got simplified to 8x squared y to the second plus 26. And then for your area, you have to know that area is your length times width. Our length is our 4x squared y. Width is 13x. So now we have to make sure we combine these coefficients. This got simplified to 52x to the third. Okay. So if you want to go ahead and try 16, let's just see if you get on the right track for your perimeter. Remember, in a rectangle, opposite sides are congruent. So this is also 10x squared. And then opposite sides, so this is also 7xy squared. And when we add all of them up, where is it? Oh, come on, sorry. This one comes out, I thought I had it up here already. The perimeter comes out to 20x squared plus 14xy squared. Your area, length times width, should be 70x to the third power y squared. Okay. Now I'm gonna address 19 because I kind of have it set up here. So perimeter. Perimeter is your distance around the triangle, so we're just adding up all three sides. And your like terms are the 4xy and the 7xy. So this gets simplified to 11xy plus 3x squared, okay? Now your area is doing base times height divided by 2. Your base is the 3x squared. And your height right here is the 4xy. So when we substitute our values in, we want it to simplify. So we do the multiplication. I'll give this 12x to the third y. And then I could divide 12 by 2, which is why our final answer is 6x to the third y. All right. Now, the next section, part of Unit 7, was exponential functions and using calculator application. So you got to be familiar with your calculator to help you problem solve. We kind of covered these in class. You do need a calculator. If you don't, you can try to Google a free TI 84 plus. There are some sites to help you do that. I know Android, you can put the TI 84 on there for free on your phone. So you can try your phone options as well. I'm going to go to 21 because we had some issues with that parentheses. When you go to y equals and you put in your fraction 1/2, you need to arrow to the right and do your parentheses. And now we're putting in another fraction. So the parentheses gets larger because we got a fraction box. And we're doing 1/4. And then we arrow to the right and we are going to close the parentheses and raise that to a power. We use this caret key up here above the division bar to a power of x. All right. So the first thing they want us to do is create a table or fill in our table. The table is going to help us graph our exponential function. So you have to hit second graph. And our table has to go from a -2 to a +2. So we're just going to copy these values into the table. And put that in here. So we're going to have 8 0.2, 0.5, was it 1/16th, I think? I'm gonna double check. 1/8, and then 132. All right. Now, it will also give you the decimal answer. So I did have some students end up putting, instead of the 1/2, change this to 0.125 and 0.8125, I think it was, or 825. Hold on, let me see. So I think if I arrow, yeah, if you arrow over and highlight, oh, it's not showing. There's a way. Let me see if it let me convert it. Oh, it's not showing it that way either. You go to the graph. Oops, we don't need to do that. I can trace my points and see the decimal ones here. So, all right, so we're going to sketch our graph. So this graph is curving and then getting close and close. So it looks like it's getting on top of the x-axis, but it's actually just approaching it. Okay, so this is decreasing, so this was a decay. Your domain is always all real numbers. In order to get the range, you have to understand the asymptote. This was in our foldable for exponential functions. The asymptote is the horizontal line that the graph approaches. Our asymptote, because this graph, it flattens out like right here, is the x-axis, which goes through 0. So really our asymptote is the horizontal line y equals 0. And since our graph is above this line, our range should be y is greater than 0. So once you know the flat line, the horizontal where it flattens, then you can get to your range. And then our y-intercept is our initial value. It's always when x equals 0, so I can get that from the table. So it's our order pair 0, 0.5. Okay, or 1/2. Now here, your calculator can help you get to these answers too, because you can map them together. So like if I look at the first equation, we have, was it 2x, 2 to the power x? And then we graph it, and we're trying to find which graph is most likely. The key component is to see our y-intercept. This y-intercept is at 1. So when I look, and it's curving up. So I'm looking for a y-intercept at 1, which is right here. Yeah. This is kind of misleading because the graph is curving like this, like that. This line is pointing to, this is not part of the graph. It's pointing to the point that they have right here, which is y-intercepts. The key to this is finding that point and looking at the shape of your curve. So here we should have B. Now the other way, if you remember on our foldable, we learned that the exponential function, it has the form like this. It's y equals a, then we have parentheses, then we have a b inside that parentheses raised to a power of x. And to find the y-intercept, which is the initial amount, yesterday we focused on this a. So if I see a number in front of the base, that would give me my exponent. And I know, like on this first one, it doesn't look like there is a number, but there is. Because I could put this in parentheses like that, and then that would mean that there was an invisible 1 there, which is why our intercept is at 1. So here, there's an invisible 1, a negative 1 here. So that would make this one A. If you use your calculator, you can check it that way as well. But we should end up having A. This one was D. We should have F here. It's positive, and it's a 1/2. Then we should have C for 26 and E for 27. Do your matching. You could always use your calculator to look at the